Wave 6, standing waves. Now, there's two types of standing waves. We've got the transverse and the longitudinal. So this one is about transverse standing waves. We have a vibration generator, a piece of string which is under tension by hanging some masses on. And what we're going to get is two waves traveling in opposite directions interfering with each other. So two coherent waves. What's happening is the wave will be interfering with its own reflection. Now, what happens is we get pretty patterns. When two coherent waves travel in opposite directions and meet, we get a very special type of wave called a stationary wave. Now, it'll be a lot faster than my animation here, but you'll notice that it's very different to a progressive wave. There's parts of the wave where the amplitude is very, very big, and parts where the amplitude is 0 all of the time. It's a stationary wave. The first pattern, if you slowly increase the frequency, is one loop, and that's the lowest frequency, and it's called the fundamental. Where the string doesn't move is called a node, and where the amplitude is greatest is called an antinode, and the fundamental, the first harmonic, is one loop. Standing waves only occur at certain frequencies because the length of the string must be a multiple of loops, where each loop is half a wavelength. So on the first diagram for the fundamental, the length of the string is half a wavelength. For the second harmonic, the length of the string will be a wavelength. For the third harmonic, it'll be 1.5 wavelengths. Musical instruments, lots of them have vibrating strings. When you actually pluck a guitar string, you will get the fundamental and all of the other harmonics. You'll actually hear the fundamental because it will be the loudest, so we say that it will be dominant. And the other harmonics are there, and they will contribute to the tone, the actual overall sound of the string. Here's a question for you to have a go at, have a read of it, pause the video, have a go, and I'll show you the answer in a couple of seconds. And here it is. And hopefully you remembered that for the fundamental, the length of the string is half a wavelength. Here are a couple more standing waves. In a microwave oven, we get standing waves set up, which heat up the food. This is why we have a rotating turntable, so that all of the food gets hot. You might have seen an experiment using if you take the turntable out, you can measure the speed of light using a microwave oven and some chocolate or marshmallows. YouTube it, it's pretty amazing. And then later on in the course, we'll talk about electrons in atoms being like standing waves, and we can work out some very interesting things there.